Now that you're familiar with the logic gates, the logic expressions, and of course the truth table, let's try and apply this knowledge to certain statements. So, first we are going to understand what is a problem statement. It's a statement when a logic problem is described in natural language. That means it's giving you a situation and then you are given a criteria for the logic of the problem with the description. So let's understand this with the help of an example. We're going to use few examples and this is our example 1. So it says a factory manufactures soap and has a system that monitors the manufacturing process. The system has 3 conditions to monitor the acidity, the temperature and the pressure. The conditions are as below. So now there's this table that provides you the input. Since it says there are 3 conditions, there are 3 variables A, T and P. A is representing the acidity, T represents the temperature and P represents the pressure. Look at the inputs carefully. Each input has got 2 values 1, 0, 1, 0 and 1, 0. To represent each binary value, there is a condition or a criteria. That means if A is 1, pH is less than 7. A is 0, that means pH is greater than 7. Same happens with T. T is 1 when temperature is less than 50 degrees centigrade. T is 0 when temperature is greater than 50 degrees centigrade. P, the pressure is 1 when pressure is greater than equal to 75%, or P is equal to 0 when pressure is less than 75%. Now this is the background or the problem statement. Now there is a condition given to you on the basis of which you need to derive the logic expression following the logic circuit and the truth table. So let's go one at a time. What's the condition? It says the system will sound an alarm X when these conditions are detected. What are the conditions? The pressure is greater than 75% and the temperature is greater than equal to 50 centigrade, or the temperature is less than 50 centigrade and the pH is greater than 7. So let's say we are interested in the first. Let's name them as first, second and third. So altogether we have got 3 statements. Let's try to relate these statements to the given table. So it says the pressure is greater than 75 degrees. So you need to look for the pressure. The pressure is represented by P. So P, and it's greater than equal to 75 degrees. This condition, so P is equal to 1. And you have to write the gate as it is and followed by the temperature. Temperature is represented by T. So we use T. The temperature is greater than equal to 50. So greater than equal to 50. So T is equal to 0. Then you have to write the OR as it is OR. And then let's go to the third statement. The temperature. Temperature again is represented by T. But here the temperature is less than 50. So if you look at this, less than 50, its T is equal to 1. The AND gate is as it is AND. And then we have got the pH, which is represented by A is greater than 7 is equal to 0. So this is the explanation for this whole thing. Now let's try to write the logic expression. So I'll move it a little bit ahead. So we are going to write the logic expression. So the logic expression says X is equal to P is equal to 1 and T is equal to 0. We have to write the OR gate. And then the second statement, T is equal to 1 and A is equal to 0. Now let's put this together, which is equivalent to P is equal to 1 remains P. The AND gate remains AND. T is equal to 0 becomes not T. Or T is equal to 1 remains as T and A equals to 0 becomes not A. Let's try and put this into the Boolean algebra. I do hope you remember from our previous lessons. So for the Boolean algebra, X is equal to P. The AND is multiplication. The not is the bar on the alphabet. So T The or is plus sign, T remains T, and is the multiplication sign, A, and not is the bar on the top. Next job, logic circuit. We have got three variables. Looking at the table, I'll just scroll. Use the variables in the same order, A, T, P. So we are going to just use the same order. So it will be A, T, and P. These are the three input variables we are going to use. Now let's follow the instruction in the logic expression. It says P and then it's T naught. So T with a triangle sign and the naught. Between the two, there's an AND gate. So let's put the AND gate together and leave it there. Then we have got T. Remember, since it's T, it should be before the naught. So T, and then it says A naught. So again, to make A naught, use the NOT gate, the triangular sign, and then the two together give us AND. And between the two AND gates, there is a OR gate. And the output is X. How do you check that? This 1 gate, 2 gate, and 3 gates with 2 NOT gates. So we have got 3 main gates and 2 NOT gates. That's how we get to know that the logic circuit is perfect. Now let's try and put a truth table together. So the next is the truth table. I'll just put the expression again here so that it becomes easier for us to trace the truth table. It's P and not of T or T and not of A. So the number of variables are three. That simply means rows are 2 to the power 3 equals to 8 and the columns are equal to the number of variables, which is 3. We have got the rows and columns decided. Let's make the table. 3 columns, since we have got the 3 variables, 2 and 3. We'll keep adding more as we require them. The first row is for the variables. Then we need 8 more. 1, 2, 3, 4, 5, 6, 7, and 8. The question arises, how do I put the variables in which order? So look at the either look at the table which was given to you right at the top, ATP, or you can follow the logic circuit, because the logic circuit is also based on the same. You must use the same order. So this becomes your A, T, and P. Now let's enter the initial values. 1 time repetition, 0, 1. This is 2 times repetition. And this is 4 times. Now let's take the first one. If we want to solve the first one, which is this one, we need the complement or the knot of T. So let's make the knot of T first. It's opposite. So 1, 1, 0, 0, 1, 1, and 0, 0. This will help us to combine the first expression, which is, let's name it as 1 is equal to P dot T complement. So we have to take this and this. P dot, it's multiplication, 0, 1, 0, 0, 0, 1, 0, and 0. Now let's try the next combo. So again for this we need A complement. So let's do that first. A complement, it's opposite of A. So we have got 4 ones and 4 zeros. Now let's put this together. So let's name it as 2. 2 is equal to T dot A complement. So T is here and it's A complement. So it's multiplication again, 0, 0, 1 and 1 is 1, 1 and 1 is 1, 0 and 0 is 0, 0 and 0 is 0, 0 and 0. Now let's get the output X. x is equal to 1 or 2. It's the plus sign, so it's or. So we have to take this and this. 0 or 0 is 0, 1 or 0 is 1, 0 or 1 is 1, 0 or 1 is 1, 0 or 0 is 0, 1 or 0 is 1, 0 0 is 0, and 0 0 is 0. So this completes the truth table. Let's complete it together and join the lines carefully. I hope it's clear to you now. Continuing with the application of these logic gates which form a logic circuit, let's have a look at another problem statement as example 2 over here. So let's get started. The scenario, the background says a wind turbine has a safety system which uses 3 inputs to a logic circuit. So 3 inputs means we have got 3 variables. A certain combination of conditions results in an output x. So we need to find how the result is going to be x, and it has got further the detail saying when the value of x is equal to 1, then the wind turbine is shut down. So irrespective of the background, what you need to put together or understand from this whole scenario is how would x become 1, which is going to help the wind turbine shut down. And then it says this is the tabular format of the parameters, which are the turbine speed, bearing temperature, and the wind velocity. Each parameter description is represented by a parameter STW, and each parameter has got the binary value which is going to be either 0 or 1. And if you look at it closely, when S is 0, the turbine speed is less than equal to 1000 rotation per minute. When S is equal to 1, the turbine speed is greater than 1000 rotation per minute. That simply means for each parameter, the 2 values and the value is directly related to the condition. So how do you solve this whole question? Let's say the output x will have a value of 1 if any of the combinations are true. So there are 3 combinations given over here. Let's try to solve this combination. It says either turbine speed is less than equal to 1000 rotation per minute and bearing temperature is greater than 80 degrees centigrade. Let's try to put this into a logic expression. So turbine speed. Now let's relate this to the table. Turbine speed is represented by S. So we are going to just put S together. It's less than equal to 1000 rotation per minute. Less than equal to 1000 rotation per minute is represented by the value 0, the binary value 0. So S becomes 0. It's added using the AND. So you're just going to put the AND as it is over here. And then it says the bearing temperature, which is represented by T. I'm going to write it together so that we don't forget it. Is greater than 80 degrees centigrade. So we need to find out where T is greater than 80 degrees centigrade, what is the binary value. So if you look at it closely, it says 1 means bearing temperature is greater than 80 degrees centigrade. So T becomes 1. And we're going to just leave it like that. Now let's move on to the next. For now, we are not using the or. We'll use them later on. So next it says turbine speed. Turbine speed again is represented by S is equal to, now the speed is greater than 1000. That simply means S is equal to 1. We are going to write the AND as it is. And then it says the wind velocity is greater than 120 kilometers per hour. So wind velocity is represented by W. So we write W. It's greater than 120. So greater than 120 means W is equal to 1. So that becomes the second logic expression. Now let's have a look at the third. It says the bearing temperature. Bearing temperature is represented by T, and the temperature is less than equal to 80 degrees centigrade. That means T is equal to 0. We are going to use the AND as it is. And then it says the wind velocity, which is represented by W, is equal to, it's greater than 120. That means it's equal to 1. So basically you have got this logic expression created for all these statements. Now we are going to look at the combination, how we are going to combine this. So let me put it together, logic expression. So let's get started and put these statements together. X is equal to 1 if, so we need to start with x S is equal to 0. That means it's represented by not of S and is as it is, and then you write T. These individual expressions are combined using the OR. So OR, next, S is equal to 1, so it's S and W. Another combination, so OR, T is equal to 0, so that means not T and W. If you notice the things clearly, the variables inside one particular expression are combined using the and then the different conditions are combined using the OR. This is simply in relation to the truth table where we had got all the expressions where the output was 1. So now let's try and put the Boolean algebraic equation together. X is equal to not S is represented by a bar on the top of S and is the dot sign. Then you have got the T, or is the plus sign, S and W, or is the plus sign, not T. T with a bar on the top and is the dot sign and W. So this gives us the Boolean algebra. Put a logic circuit together for this logic expression. So logic circuit. To draw the logic circuit, make sure you have got the variables in the same order as given in the table so that there is no confusion. So S and T we are going to start with. It says S complement or not of S. So you need to make the little triangle and then the circle in front. It's combined with T. So let's put these two together. It's always worth bringing them closer so that it's clearly made logic diagram. So this is the first one. Let's move with the second. It says S dot W, that means S and W. So we are going to use S from here. We need W. So we are going to take the third input variable W, and between the two again another AND gate. If you look at it closely, between these two there's an OR gate. So let's complete this equation. So it's here and then you have got the OR gate to be combined with the third expression. So the third expression says T naught dot W. To take the T naught, you need to just make another little triangle over here. T naught, and then W you can take straight. And between the two, you have got the AND gate. This is combined with the previous OR gate to get the final OR gate as X. So this becomes the overall logic circuit. And now we are going to try and put a truth table together. Once you have got the problem statement clearly understood, or you can make sense out of it, you can make the logic expression, the Boolean expression, the logic circuit, or the truth table. It kind of relates with each other. So 3 variables, that means we need the 8 rows. So let me put it together. The rows are 2 to the power 3, that means 8. The columns are going to be 3 itself. So we are going to put this together. So let's get started one at a time. I'm going to use the topmost for the expression or the variables, and then after that 8 rows we need. 1, 2, 3, 4, 5, 6, 7 and 8. Let's put the 3 variables together, S, T and W. The input remains the same, one time repetition, so it's 0, 1, 0, 1, 0, 1, 0, 1. We have got 2 zeros, 1, 1, 0, 0, 1, 1, the 4 zeros and 4 ones. So we are ready with the input values. Now let's have a look at the logic expression. I'm going to use the Boolean because it's easy to write. So first we'll take S complement dot T. That means S complement dot T, we need the multiplication of S complement with T. So opposite of S, it becomes 1, but it's 0, so 0, 1, 0. I'm taking it 1 because I'm doing it directly. You can put another column if you're finding it a little bit uncomfortable, but you can do it directly also. It's complement. Opposite of 0, 1, 1 times 0, 0, 1 times 1, 1, 1 times 1, 1, 0 times 0, 0, 0 times 0, 0, 0 and 1 is 0, 0 and 1 is 0. So this is the first one. So now let's have a look at this second one. It says S dot W. So we are going to directly multiply the two, S dot W. So it says S and W multiply 0, 0. Anything multiplied by 0 is anyways going to give you 0. So whichever side you have 0, it's going to be 0. This time we have got both 1, so 1, 0 and 1. Now we have got the third expression, that is T complement dot W. So let's put that together. T complement dot W. I'm just going to use directly as well. So T, opposite of T, 1 times 0 is 0. 1 times 1 is going to give you 1. 0 and 0 is going to give you 0. 0 and 1, 0. Remember, it's T complement. 1 and 0 is going to give you 0. 1 and 1 gives you 1. 0 and 0 gives you 0. 0 and 1 gives you 0. Now the last and very important thing is X, which is a combination of all these expressions X. You can add them together. It'll be the same result or the outcome. So 0 plus 0 plus 0 is going to be 0. Because there's 1, 1, it's going to be 1, 1, 1, all zeros. 2 1 still going to be 1, 0 and 1. Basically, you need to remember that you're not going to add them in theory. Like you won't do it 1 plus 1 or 2 or 1 plus 1 plus 1 as 3. We'll see how the binary addition takes place. So this is the result or the outcome of this whole expression. So we have got it solved. So we will look into one more example to apply this logic expression from a problem statement. Let's try one more example as problem statement 3. So let's read the scenario that's been given to us. It says a safety system uses 3 inputs. So we have got 3 inputs again to a logic circuit. An alarm X sounds if input A represents on and input B represents off, or if input B represents on and input C represents off. The question is to draw a logic circuit followed by the truth table and show the conditions that cause the output X to be 1. So let's get started. The first and very important thing we are going to write is the logic statement representing the scenario in this statement, in this example. So let's put it together. Logic statement representing the scenario. This will make it clear when we are going to get the value of X. So representing the scenario. So let's read the example again, and it says A represents on. So I'm just going to write that together. How is A representing on? So let's put this together. A represents on. A is on. And in the same condition it says and B is off. And then there is an OR. So we are writing the OR separately. Or B represents on, B is on, and C is off. This is the explanation for this whole scenario. To put this in the logic expression, you need to recall the little table we had used right in the beginning that says if you have got on, it means 1. If you have got off, it means 0. So this will help us to put it together. So the logic statement here becomes A is on, that means A is 1. So X is equal to A is on and. So we are going to write and as it is. Now B is off, that means B is 0. So B is not of B. There's an OR in between, you have to write OR as it is, and then let's move on. It says B is on, that means B is 1. So B is as it is. We put the and together. And then it says C is off, that means C is 0, which means not of C. Now let's put this into the Boolean algebraic expression. So X is going to be A and is represented by dot, not B. The B with the bar on the top, or is the plus sign, the B as it is, and is the dot, not is C with a bar on the top. So this becomes the Boolean algebra. I'm sure by now you are expert with the logic circuit. Let's get started. Logic circuit. Whenever you have got a problem statement, you can produce the logic statement, the Boolean algebra, the logic circuit, and the truth table. They're all interrelated. So we have got the 3 variables A, B, C. So let's get started. A, B, and C. These are the 3 variables. one input, two input, and three inputs. So it says A with the B complement. So we are going to use the B complement that comes over here, and then we have got here, and there is a and between the two. So and then it says B. So remember, take it from before the not sign, else it becomes wrong. And then C is complement. So you're going to make that little triangle, and then you've got the two together. If the distance is close, you don't have to bring it together because it'll be easy for you to join it together anyways. And then between the two, there is an OR gate. So let's pull them together. And then this is the OR gate that gives you the output X. So this is how it looks like. Now let's try to put a truth table together. Since we have got the three variables, we'll need the three inputs. So to put a truth table together for the above equation. So let's get started. Truth table. Let me just write the equation over here. It makes it much easier. X is equal to A dot B complement plus A dot B complement plus B dot C complement. Now, since the number of variables is 3, the rows are 2 to the power 3, that gives you 8, and the columns are straight, that's 3. Now, let's get started. So, make a table. The first row is reserved for the variables and the expressions. Then we need 8 more rows. So, let's go. 1, 2, 3, 4, 5, 6, 7, and 8. So let's have the three variables as they are A, B, C. So it's A, B, C. One time repetition. Then it's two time repetition. And then it's 4 times. So 4 zeros and 4 ones. Let's pick up the first. It says A dot B complement. If you struggle to do it directly, you might want to write the B complement separately. So it's completely up to your discretion how you want to do it. But you can do it directly also, because in any case, when you multiply by 0, it's going to be 0. So if you look at these 4 zeros, it's going to give you 4 zeros directly. Now here is the trick. So 0 becomes 1. 1 time 1 is 1. 1 time 1 is 1. 0 is 0. Because it becomes 0, so it becomes 0. So this is what you get. Similarly, we are going to solve the next one, which is B dot C complement. So let's get started again. B is 0, so even if you convert C into C complement, it will remain 0. So now C becomes 1, so 1 time 1 is 1, 0, it's 0, 0 and 0 is 0, 0 is 0, this is 1 and 1 becomes 1, 0 and 1 becomes 0. Now the last we are going to get is the X by adding the 2. So 0 and 0 gives you 0, 0, 1, 0, and then you get 1, 1, 1 and 0. Remember, it's the addition. Addition does not mean 1 plus 1 is 2. This is binary. Here we take as if both are 1. That means the output is 1. So you don't add them even if you get the ones together. So this is the final outcome from the truth table.